from a developer perspective, how can you shift responsibility, and what kind of practices and capabilities that you can use and apply early on in the development cycle and throughout the building of the application images, so that you can have a more secure application. So in general, AKS has a large set of comprehensive security controls across all of the stack. Like at the container image level, it starts with image scanning, runtime scanning, threat analysis, and more, which is powered by Microsoft Defender for containers. And then on the cluster control plane level and the nodes, they can be secured with a number of features and capabilities, such as like private clusters, encryption, and policies, confidential nodes, confidential containers, and a bunch of other features that we'll cover in the operator track after lunch. And finally, at the application and network level, there are certain practices that can help improve the security posture. So in the coming section, we'll go over some of these practices and how they can improve the application security. So I'd like to start with the container image. The container image is one of the biggest sources of vulnerabilities and security issues that might come up in your app. If you build your application today, a few days down the line, a vulnerability might come up in one of your dependencies or one of the base images that your application container image is using. And keeping up with the updates of that is a hard thing to do. It's tedious. It requires a lot of focus on seeing what CVEs are being published. You have to go and look at your images, which base images you're using in your Docker container. You have to rebuild the image. It's a lot of work. It's important work, but it's a lot of work. And for this reason, we have a new feature that's currently in private preview in Azure Container Registry, which is called the image auto-patching. And what it does is that it detects vulnerabilities within images that are hosted in Azure Container Registry. And it's able to directly patch those images on Azure Container Registry without rebuilding the application or without rebuilding the image again. So it's directly patching layers within the container image. And how it works is that you can then wire this up to events or callback functions that can call your deployment pipelines to update the container image tag within your Kubernetes deployment, so that automatically it gets the new patched versions without a lot of manual intervention. And I'd like to show you an example of how this looks like. So in here we're using a tool called Trivy. So Trivy is a vulnerability scanner, and we have a vulnerable image of Nginx that has a number of 259 vulnerabilities in this image. So in this example, we're creating a task on Azure Container Registry to do continuous patching. So what you're saying here is that I want to incrementally patch this container image, which is going to be on Nginx, and I'm going to be patching only versions 1.21 that are on the container registry. And then with the CLI, I'm going to do the supply chain CLI command, which is a new command here. And once I submit that task to ACR, to Azure Container Registry, it will detect that this is actually running this image with these hundreds of vulnerabilities, and it will trigger an image update, and it will generate a new version of this application. So when you see this on the left, we have the repositories and Nginx. Then you'll see that we have a new version, which is 1.21-1. And now if you scan that, we should have 0 vulnerabilities. And from a developer perspective, I find this really helpful that I don't have to go in and rebuild my application pipeline. I can make sure that my application-based images and my applications in general are kept secure and up to date, drastically reducing the amount of work that I need to do to keep the app secured and patched. So this feature is currently in private preview. And if you'd like to have a look and I'd like to test it out, I can share the link back here. It's aka.ms /ACR/patching/preview. You can sign up and you can try this out. So beyond the image security, following Kubernetes workload best practices and security best practices hasn't been any easier right now. So we have the Azure policy integration and the Azure deployment safeguards, and both of them can enforce policies on the clusters, and they can enforce policies on the things that you're trying to run within those clusters. So for example, within Azure policy, we have a set of policies that together they're grouped and they're called the Pod Security Initiative. And they are a set of policies that enforce things like your containers cannot run as root, your containers cannot mount the root file system, your containers need to run with a non-root user to get less elevated permissions. So that's from a security perspective, but also from a workload reliability perspective, it can enforce things like having resource limits and requests in the deployment, not using the latest stack, for example, and so forth. So between the Azure policy and deployment safeguards, together both of these features are built on top of the open source Gatekeeper project. And they apply and enforce the policies on your cluster right away. So I'd like to show a demo of how this works. So in this example, I'm applying, I have an application that's deployed already, and I'm redeploying it. And it's using a bad practice, which is using the latest tag on the container image. So it's telling me that right now deployment safeguards is in the warning mode. So it's not going to block me, but it's going to tell you that, hey, consider using an explicit version tag when you're deploying the app. And why? Because you never know what you're going to get with the latest tag. For example, in this case, the latest tag, someone pushed something that broke the application, and the application is now crashing. So we need to fix that. So the first thing I would fix is switching deployment safeguards from warning to enforce to stop this from happening. So if I update the cluster and update the safeguards level to enforcement, trying to deploy that application again, or trying to deploy the same manifest again with the latest tag will be blocked. And the way this works is that there's a admission webhook, a validating admission webhook that works with Gatekeeper and works with the policies that deployment safeguards creates that will block this from happening. So it's here that there's an error, there's a forbidden error from the server saying that you cannot use the latest tag because that's bad practice. So if we fix this now, the deployment should go through. But not only that, you see that there's a mutation being applied up there, which I'll come right in a minute.
And this is on a subscription level, right?
It's on a cluster level. So this is applied at a cluster level. So it also mutated the deployment to add a resource, the missing resource and request limits for me. Essentially enforcing those best practices. So for those rules that can be mutated, deployment safeguards will mutate them in enforcement. For other rules that cannot be mutated for safety reason, or there's simply no way to know how to mutate them for you, we will block that deployment from happening until it gets fixed. And as a security best practice, it is generally recommended to store secrets outside of the cluster. So if your application is using API keys, it's using connection strings, it's best not to store this in the cluster. It's best not to store this in source control, of course. So for that, it's better to use a centralized secret store. Azure Key Vault provides a service for storing any sensitive things that you need to tightly control. They can be API keys, they can be SSL certificates, they can be connection strings, they could be encryption keys, anything that your application needs to store as a secret. And Azure Key Vault works with the Secret Store CSI driver to synchronize secrets from Azure Key Vault as Kubernetes secrets on your cluster. So it acts as a CSI driver. It can mount those secrets as Kubernetes secrets within your deployments. and it can even do things like secret rotation. So it can listen to changes or periodically refresh the secrets from the cluster in case, for example, you're using this to load SSL certificates to apply on your ingress. When you change the SSL certificate to renew it, it can then pull the new one and apply it to the ingress without a lot of manual intervention. And for other non-secret application configuration, the Azure Application Configuration Service can also centrally manage that. And the nice thing about it is that you can use this to manage settings, you can manage feature flags, and with that extension, you can synchronize those settings either as secrets or as config maps. And this allows dynamic reconfiguration of the application without you having to go in and change those settings and redeploy. So think about it as well that you can have application configurations per environment controlled from the Azure configuration service, where, for example, you'd say on staging environments, these are the set of variables or values for the variables that I want to use. For production environments, these are the set of variables I want to use. And from the application using the Azure configuration extension, it can load that based on the environment that it's running in. And as you create applications that need access to protected resources on Azure, such as databases, there's a preferred way to do this, which we've briefly talked about yesterday in the lab, which is using workload identity. So a workload identity is a better way to access such protected resources as opposed to using connection strings or simply passwords. Workload identity is a managed identity in Microsoft Entra. And what it does is that it allows your application to exchange a trust, federated trust that it has, for a token to access that Azure resource. And it works with a couple of libraries. So if your application is using the Azure Identity Client libraries or the Microsoft Authentication libraries, which are available in a number of languages, you can seamlessly pull such token information and authenticate your application using workload identity. And the way it works is that you create a managed identity, you grant that managed identity on Azure access on a particular resource, for example, a database with a role, and then you establish something called the federated identity credential, which simply ties a service account in Kubernetes running in a namespace to an identity so that Azure says that if that service account requests to authenticate to that Azure resource, that is allowed. So it's establishing this sort of trust within a namespace inside the application where the application is deployed. Now, to configure workload identity specifically, there's a number of steps that you need to do. So you need to configure this managed identity, you need to configure the permissions, you need to create the federated identity credential, you need to update your applications to use that, you need to create the service account. So for this reason, we've created this service which is called Service Connector that abstracts these setup steps from you so that you can easily do that. So what it does is that it can grant access to proper role assignments and firewall rules and network permissions on the target resources that you want to connect to. And it can configure the firewall settings. It can configure the service accounts as well as synchronize the secrets for the environment variables that it creates into the cluster so that the application is able to access that connection. And I have a short demo as well for how to do that. And in this example, we're going to be using Service Connector to configure an application we've already deployed to connect to Cosmos DB with workload identity. So Service Connector, you can find it in the Azure portal under the Service Connector blade. And you can create a service connection. Service Connector supports over 30 Azure services right now. So you set the namespace that you want to configure that in. And then you pick the target service that you have. So in this case, I have already a Cosmos DB that's deployed. And I already pre-created a managed identity that I want to grant that access to. And hitting next, Service Connector will configure the permissions And then in a few minutes, these environment variables, which will pop up now, will synchronize to the cluster that I'm working on as secrets that I can use in the app. So for example, if in a minute here when I expand this, you have the Cosmos DB connection string or endpoint, client ID and scope. And then to configure the application actually to use it, just a second, you can pick the workload that you want to configure that's running in your deployment on your namespace. For example, this is the app. And Service Connector can then inject the workload identity label, the secret reference, as well as the service account name, and will automatically update the application that's running on your cluster so that it can now have access to Cosmos DB. And that's not the only way you can do it. So for example, you can copy that YAML, and then if you're using CI/CD, you can then store that in your CI/CD pipeline so that it's not a one-time thing. You had a question.
Yeah. Is it only available for the AKS automatic, or is it
So the question was, is Service Connector only with AKS automatic? No, it's across any AKS cluster. And with that, I'd like to invite Karthik to stage to talk about how to make the application that we're building resilient and scalable. So Karthik, over to you.
Thank you.
Hey everyone, hope you can all hear me okay. So my name is Karthikeyan, I am a senior PM at AKS. I'm also going through a bit of resiliency and fault tolerance, having been jet lagged so the last couple of days, but not to worry, I'm mostly surviving on chai and coffee. That's my go-to. Nothing like what you're going to see here. So workload resiliency focused approach. There are three pillars broadly. In terms of platform reliability, upgrades and deployment, that will come later in the day as we go through platform and operator track. But for today and for the purpose of this developer track, I would ground myself into the application resiliency bit, and that's what we are going to focus on. So if I have to break down application resiliency, deployment configurations, you're looking at state management and resiliency bit there. How can we introduce chaos testing to a point where you can test fault tolerance and what is the breaking point for my application, right? And then load testing, which is nothing but a fancy way of saying how can I simulate real world traffic. And that part to do with chaos testing is very powerful to go end to end from scale to fault tolerance. And how many of you here have been subject to some form of workload disruptions, especially when you're going through upgrades, maintenances? Okay, I see some nods as well, but you can also put your hand up, so that's fine. I think many of you, Lucky covered it yesterday as well, if in case you attended the lab. So many of you are not really aware or using what is a very powerful concept in Kubernetes called pod disruption budget. It's a way for you to ensure availability of your critical workloads and pods, and that is by defining what is the minimum availability and maximum unavailability, right? So here is an example there. You can set up PDB. So basically, once the PDB is there, Kubernetes and AKS always honors the PDBs, right? When it comes to evicting the workloads and making sure that your critical pods are available. And then in terms of coming to resource-intensive applications, right? You can always use stains and tolerations and try to pin them to the correct set of nodes in terms of mapping pods to the node. So that way, you get in terms of managing the intensivity of the applications. Node selectors, node affinity, topology spread constraints are other means to control the scheduling of the pods. I think I probably missed the bit where In terms of setting up the request, resource request and limits comes into the picture, especially when you're using things like HPA and VPAs. So that's another bit all through we can ensure availability. And how many of you here have actually used Chaos Mesh and Chaos Studio for? Okay, I see one hand up. It's something that we definitely recommend for fault tolerance testing. Azure Chaos Studio uses what is an open source offering of Chaos Mesh, and basically it's nothing but introducing fault tolerance by both at the infra level. You can actually take down VMs, availability zones, etc. Or at the deployment and application level, where you can choose to kill certain pods, restart, delete, and try to introduce some chaos, right? And thereby push and see where your application breaks and how fault tolerant it is. So it's pretty important, especially you can try it in the lower environment. And as you not definitely recommended jumping into production and doing it, but you can take it phase by phase. Multiple zones for high availability, especially when we are dealing with AKS clusters. You have this concept of zone selection with topology spread constraints, node affinity, and that brings about what we call application level replication. There is also zonal replication with ZRS, which I think Shekhar covered a little bit. So that's important because it helps you to write across the 3 availability zones. So you can always move zones in case there is zonal level failures with and we're happy to introduce force detach of zone redundant storage, which is now available, and it is what your disk CSI driver adopts when to do the force detach capability. That's quite crucial as we are talking about zonal level redundancy. You can think of ZRS disks. If there is attached to a particular VM node is impacted with a zonal failure, can quickly recover by moving it into another zone that is available. So this disk force detach is something that you can, yeah, go ahead.
Azure Chaos Studio is pay-per use or is it just the add-on?
It is, I think, it is not pay-per-use as far as I recall, but I can double check. So the question is, what about the billing metrics from? Yeah, I can get back to you later on that. So I have a quick demo where, so I have in a user pool 3 pods which are placed to 3 nodes, and then you have a system pool that is having 3 nodes. So what you're going to do is create in Chaos Studio experiments, whereby the first set of experiment is introducing a fault. I'm going to take down specifically selective nodes where my pods are running in the user pool. To start off, you can introduce a custom role with system assigned identity. That's the only thing needed. And then you can go ahead and create the experiment in terms of, I'm using node auto provisioning underneath it. And you can see the resilience in action of NAP nodes. I'll probably select a couple of nodes here in the user pool where my pods are placed and take it down. So I'm just selecting a couple of nodes. And the second bit is on the availability zone. So that's the part where on the system pool, specifically I'll try to take down the zones from the system pool and see, because that's where some of the managed add-ons are running. So see that resilience also in action. So we have topology constraint also put in here and with NAP, and we'll see in action how things get back as we do a chaos experiment. Yeah, selected a couple of zones to take down. It's pretty easy to quickly create. So we've started this. And remember, the 3 parts are specifically tied to 3 nodes. So you will see them go unready and quickly come back to ready state. That's the node claim there, and you can see a couple of nodes going to not ready state, and quickly NAP retrieves them back, realizes that it benefits from creating one more extra node here in this instance. So you'll see at the end we're left with 4 nodes. But although as you started on the contours of our deployment, there will be just 3 pods and 3 nodes. And you'll also see that the system pool nodes go from not ready to quickly to ready.
I have a question.
Yep.
So can we capture a report on a portal anywhere as a dashboard, or can we have that metrics capture a telemetry collector can capture all the metrics, and where we can visualize as a dashboard?
Good question. So from Azure Monitor offers a lot of these metrics in terms of looking at node level and container level, but also in terms of dashboard, you have managed Prometheus and Grafana integration available. So that's something you can plug and play with.
Okay. Does it scrape? I mean, does it automatically scrapes
yes,
it?
Yes, you can configure to scrape it, and you can have a real-time dashboard to see all these things.
All right. Yeah. Thank you.
That's a good question. I also mentioned there is Azure load testing, and this is in addition to what we saw in chaos testing. So basically, it's about introducing real-world traffic, user traffic, and it's very easy without any complex infrastructure, similar to Chaos Studio. You can try it out, and basically it works with in tandem with your CI/CD workflows. And it's quite easy to test load regularly, or in burst. You can also do bursty traffic and just replicate how a real world situation, just say on Black Friday deals or New Year for some of your applications, how do they react?
Hello, and I hope these can be done through ARM templates or AZ commands. Chaos testing and load testing.
In terms of load testing and chaos testing, we have, as far as I know, it's available in Portal. There's good level of this thing. I'm not sure if there's ARM
Because
template on that.
organizations generally they don't allow through Portal. There's restrictions, right? So how do we actually go about it then?
Okay, I can check on the ARM template.
Sure. Yeah, thank you.
So as we are going into from a single cluster, if you're looking at a fleet where there is a front door and you have a list of clusters each in a separate region, it's about placing your workload in the right environment and deploying also close to the customer demand. So here we have what we call cluster resource placement, and that helps you to pick from the topology spread constraints what is the right cluster in the right region, so that you can test regional failovers. With that, thanks. I just wanted to say that apps in AKS is as resilient as the local Delhi boy you see in the picture. That's about it. Thank you. And after this, I believe we have Sachi next.
Sorry about that. And yeah, different approaches for short-term and long-term cost optimization, and really going into the 3 pillars of how AKS approaches cost optimization and how we want our customers and end users to be viewing it as well. So for new and migrated workloads, we want to look at these 3 steps: inform, optimize, and operate. So with informing, this means understanding AKS usage and cost, visibility, allocation, monitoring analytics, and having the right tools in order to do so. So by raise of hands, how many of you folks have cost monitoring tools implemented for AKS today? I guess you could shout it out, but what are some of those tools that you're using? Are they AKS based or open source?
As well and AKS based as well.
Okay.
Yeah. So the cost operator.
tools too, AKS based as well.
Yes.
And of course open source as well.
Mhm.
So on AKS on the portal itself
Yes.
displays the dashboard, and we can configure ourselves like what we want to actually show. That's one thing. Open source using Prometheus, we
Yes.
scrape the whatever operator it is, right? Collects the metrics, we scrape it through Prometheus, and we are visualizing on Grafana.
Great, yeah. Those are some of the best practices that we're going to be diving into. And so that's part of the first step. Then based on those analytics, those measures, how are we going to optimize resource usage and cost? So using different Kubernetes specific tools like vertical pod autoscaler, horizontal pod autoscaler, Kubernetes event-driven autoscaler or KEDA, and then also node auto-provisioning. That's been mentioned a few times throughout as a theme based off of the open source Carpenter project. So then following that up with operate, so reducing operational overhead costs of running AKS at scale. And that's where, as Karthik mentioned, we're going to be leveraging AKS Fleet Manager for intelligent placement, and then AKS Automatic comes back in, so full circle. So diving into the first point, we want to dissect cloud spend for dev teams specifically. This is not just an operator specific like recommendation. So when it comes to allocation, monitoring analytics, and then managing anomalies. So based on what kind of trends you notice in usage over time, how are you able to detect anomalies, and how can you automate different actions in order to reduce them when you come across anomalies. So I think it was mentioned within AKS and viewable within the Azure portal, we have AKS cost analysis that is a GA feature available for standard and premium clusters. So you get granular cluster infrastructure cost broken down by Kubernetes specific constructs. The data is reported directly, pre-processed, post-processed data straight into the Azure portal UI. And it's the first cloud-native provider cost visibility experience built on top of OpenCost, which is an open source project. So we're going to be going into some of the different views within AKS cost analysis. So you can analyze app namespace and shared costs. And this is what an example of what the workbook would look like within Azure portal. So you can see the total and then average per day, per month, different time measures. And then you can view shared costs such as idle, system, service, SLA costs. And then analyzing, as I mentioned, so with the assets view, this is a categorical grouping of all the resources in the cluster. So this is a bit more easy to consume, and I'll show you how this looks in a demo video. So first, we'll go ahead and check in the cluster whether, this is a staging cluster, whether we have tracking the cost metrics. Right now, it looks like that's not enabled yet, so we'll go ahead and enable that through AKS cost analysis. And you can update this for the staging clusters right from Azure CLI. And now that you'll see that it has been enabled, so the metrics profile. So what does that mean really? We get a breakdown of the costs based on namespace and then assets. And here you can look specifically at your Kubernetes clusters that you have. And per cluster, you can dive into all of the related costs. And it's kind of grouped here based on location and then the resource group. So from month to month, you can see the breakdown of costs. And then filter to get a more fine-grained breakdown of assets and namespaces. So making optimizations based on having this all-around information is very important. So for compute, networking, storage costs, we divide that up and show those totals as well per cluster. So with any given cluster, this is what the default kind of filters look like, and then you can go in and adjust them accordingly. So within compute costs specifically, you can see the type of resources that have been allocated, budget accordingly maybe moving forward if there are different types of resources you want to allocate for specific workload types, networking costs, and storage costs as well. So the latest edition of the cluster optimization workbook, do we have a question? Yes.
Once we have that optimization analysis of any particular cluster, then how we can apply those statistics in the real-time cluster? Basically, what are the suggestions they give to reduce those
Yes.
costs?
So how to use those findings. Yeah, I'll be going into that now. So that's kind of the first step of informing, and now we want to optimize and then operate based on that information. So this new update for the workbook within Azure Monitor Container Insights, it is able to use the collection of logs and events and help optimize your cluster. So dealing with container limits and requests, especially when it comes to extremely low or extremely high CPU and memory, is often a significant problem for app developer teams and operator teams. AKS helps alleviate this by identifying those containers and suggesting the appropriate limits and the associated values. So we are making sure that your cluster is optimized for the best performance. And with this feature, specifically the cluster optimization workbook, you can easily identify liveness, probe failures, event anomalies, and right sizing of your container limits and requests. So the next step, optimizing according to the information that you have. So we'll dive into a few of these auto-scaling techniques. So there's VPA, leveraging NAP, which is built on Carpenter, alongside with Spot strategies. How many of you folks know about Spot VMs in Azure? Or have you used Spot instances before? Okay. So it's a great benefit because you have lower costs associated with them. On demand can kind of leverage those VM nodes. And then I'll go into what are multi-architecture images, what are the benefits that they provide with pulling them from a private ACR and then different types of nodes. And then from a hardware level, what are optimizations to make for your GPU compute and how that over time can reduce costs. So you can let AKS automatically scale your applications. With using horizontal pod autoscaler, you would automatically scale pods up based on resource demand, either CPU, memory consumption, or other metrics. You can also consider load balancing. If you have good load balancing between pods, then HPA is good for adding the pods, and then traffic can be routed easily to those pods. With Kata, maybe it doesn't make sense to scale based on CPU and memory. If you want to scale based on events, traffic within your application, you can also do that instead with Kata. HTTP requests, Prometheus metrics can be used with Kata for spiky scenarios and scaling up automatically, but also scaling down to 0. For vertical pod autoscaler, you would dynamically update requests and limits for your pods based on horizontal historical usage rather than scaling up number of replicas. Right-sizing your pods is most important for successful bin packing and resource utilization. And getting the requestive limits is really difficult setting that properly to avoid throttling or out-of-memory errors. So these are 3 auto-scaling techniques that you can apply in different scenarios within your AKS cluster today, as well as cluster autoscaler. So this is on the scale of automatically scaling your node pools based on usage and application requirements. You can scale up when there are pending pods and scale down when nodes are unneeded. So tuning the CAS profile to suit your application needs is an approach to this. So for bursty workloads, for cost optimization, you can adjust different fields within your cluster autoscaler profile to handle those kind of scenarios. Node auto provision. So this was mentioned previously. It is a different way of auto scaling. So based on the type of workload you have, you would allocate the resources necessary for the workload specific, as opposed to like event-driven auto scaling or the other auto scalers that are offered today, alternatively. So it would help with efficient bin packing, so consolidating your workloads on the right size infrastructure. So with node auto provision, I'll go into a few demos afterwards. It would select from a series of different VM families that are suitable for the workload type, and then based on availability, choose one of those for the workload that you have deployed. And it's a great experience for customers and built in for AKS Automatic as well. Node auto provisioning is currently in public preview, and we're planning for GA early in the next year. So some best practices for node pool scaling. You want to have a balance between cost and performance. So what we recommend is using standard tier for your production and scale workloads. The free tier is not recommended for product, mainly for dev and test environments. Often questions that we see are how many nodes and how large of VMs to use for a range of different types of workloads. So we do recommend using v4 and v5 VM SKUs since they provide faster provisioning speed and a larger system pool VM SKUs when running large AKS clusters, so on the scale of 500 nodes plus. It's a good idea to set max pods per node based on your capacity planning as well. When it comes to capacity reservations, some data centers have been seeing capacity issues, and you folks are probably aware of these limitations. So when it comes to Azure capacity reservations, reserve on demand and compute capacity in any region or availability zone for any duration of time, and you're guaranteed to be able to use it for the time period that you need it for. So with node auto provisioning, I can explain a bit more on how it achieves the cost optimization. So you can cost optimize existing nodes into more efficient nodes and consolidate with higher utilization per node. You would be simplifying your node provisioning experience and meet the requirements of pods, remove nodes that are no longer needed. So you don't want to have idle costs from your provision compute that's just kind of sitting there. So if you have spiky traffic, you can use Kata for those scenarios, but then also in addition to different types of auto provisioning techniques, reduce idle nodes in general. So spot strategies with NAP. Spot VMs can offer major cost savings up to 80% relative to on-demand VMs when paired with node auto provisioning. And you simply have to take your node auto provisioning profile and specify that you want to be using spot VMs. And NAP will choose from those set of SKUs based on when workloads are submitted. You configure separate node pools for spot and on-demand capacity, and essentially prefer those spot nodes as opposed to on-demand VM nodes. So you can configure eviction policies test spot eviction scenarios, and monitor and set cost alerts. So I'll go into a quick demo of what this would look like. Taking a look at the Carpenter manifest for AKS node pools, we can see that the values here are on-demand or spot. So then we'll go into the deployment, and essentially we want to set weights for the different types of nodes that could be considered for the workload. So you would give a higher weight to the spot nodes, which would be 100 in this case, and a lower weight of 50 to on-demand nodes. And then we'll see that that's reflected in the instance type that is provisioned for the workload. So from an infrastructure perspective, cost can also be optimized from the underlying CPU VMs that are provisioned for the workloads. So now GA, Azure Cobalt 100 ARM-based VMs are now available. These general purpose SKUs are memory optimized, and they offer a range of different improvements in comparison to other previous generation ARM-based VMs. So up to 50% better CPU performance per dollar, 300% greater local storage IOPS, so the measure in performance of how it retrieves data from storage, and higher power efficiency. And you'd be able to explore these different options within the available VMs in Azure. So when it comes to these kind of VMs, you want to work with multi-architecture images and manage them in Azure. But that might not be as straightforward. So the open source Auras tool makes this simpler. You can essentially create a multi-architecture image using this project. So it supports both image and architecture format. And what the multi-architecture image can do is that they offer better cost savings, higher performance, and have the ability to support more cores with ARM-based VMs. So for those of you with a heightened security posture, Azure supports creating the multi-architecture image locally, and then pushing them to a private ACR or container registry. Then you can pull and push them from the private container registry accordingly. So multi-architecture images may combine variants for different architectures and sometimes for different operating systems. So you essentially would not need to create separate builds, and this can reduce your total costs. So I'm going to demo what it would look like to push a multi-architecture image to ACR using the Auras project. So we're going to be creating this image locally and then using the OCI layout flag in the command line for creating an AMD 64 architecture for Linux operating system. So we're going to be using two architecture-specific image tags locally, the AMD 64 and ARM 64. And since we've made that locally, just for maintaining different versions of the image and then retrieving them afterwards, we're going to be pushing them to ACR. And we can see how it's very simple doing it just from the command line. All of these steps that are needed are automated, and then you can go to ACR portal and see all the details about that multi-architecture image right in Azure portal. So you can see the platform as well as specific tags and related information to the multi-architecture image. So again, with working with these kind of images, you would reduce the need for creating separate builds, and in that sense, have some cost savings with that. And these are just some other helpful information to using the AURAS project. So I'll also demo cost optimization with NAP and ARM. And again, it's kind of like cut and dry with working with the Carpenter profile and then going to the node pools and having provisioned SKUs that you'd be working with. So here specifically, you would be changing the architecture that's preferred. And in the node pool, so within the node selector specifically, you'd be putting AMD 64 and then apply this manifest. So we can take a look at these node pools that are in a ready status. And now see that it changes from pending, container created, and now running. And you could see within the name specifically that it's the provisioned node pools for each deployment are according to the information that we provided to the Carpenter manifest. And the instance type that's chosen is also according to the OS and the architecture that was requested. So this is kind of going to be replicated for the architectures AMD 64 and ARM 64. So I'll move on from here. Now, when it comes to making optimizations from the compute level, so for GPUs specifically, I mentioned in a previous session that GPUs are essential for different types of AI workloads. And when you have less of them or they're not as readily available, you want to optimize how the GPUs are used. So with MIG specifically, this means multi-instance GPUs, and you can partition them into separate and secured GPU instances from the hardware level. So an example of MIG-supported GPU is the NVIDIA A100. And I've heard from a few folks that A100 nodes are used for your AI or HPC workloads. So you can definitely test out MIG there and run workloads with predictable performance without interruption due to lack of resources. So you're partitioning this single GPU and using it to almost its fullest extent. And you can visit this link for our documentation on how to get started with MIG on AKS. So they're suitable for multi-tenant environments and similar to MPS in that the resources of the GPU are space partitioned. So you also want to collect GPU metrics. And this is kind of following the 3 pillars that I mentioned previously. Using metrics, you can be better informed and then take actions accordingly. So by taking GPU metrics, using different tools that are offered by, for the specific SKUs that you have. So with NVIDIA SKU specifically, you can use the DCGM exporter. So this exports usage metrics, health metrics for the GPUs. And it's just a 2-step installation, and you can customize the metrics, filter through them, use Prometheus and Grafana to kind of visualize what that looks like, and then make informed decisions accordingly. So extracting valuable insights so you can expose underutilization, overutilization, GPU node health, et cetera. And this is an example of what that dashboard can look like. It might be a lot to take in at once, but this is all very important information to either decide if you want to pivot towards other types of GPUs provisioned for your long-running workloads, or take action based on node health, maybe create separate node pools and migrate them over. So lots of different use cases for collecting GPU metrics. And lastly, we can use fleet cost-based placement policy for cost optimization. And through just this cluster resource placement right here, you can use a pick-end strategy. And with the number of clusters, which is what we provided as 2, you can select based on cost where you want your workload placement to be. So we're going to use the policy to place workloads based on cost for CPU core or amount of memory. And this is coming soon, but this is an example of what that would look like. So you'd first deploy the workload onto the clusters, and then Fleet would take care of automating what the placement would be. Sorry, deploying onto the hub cluster, and then the hub cluster automates what the placement is after that. So recap, based on these 3 pillars of cost optimization, you'd want to understand your AKS usage and costs, then optimize accordingly using different auto-scaling strategies or compute-specific optimization, and then reducing operational overhead costs of running AKS at scale. So using different solutions like Fleet cost-based workload placement, and then AKS Automatic that we've highlighted previously as well. And we have plenty of different resources for taking a look at the demos that I've showed, and also better understanding how those 3 pillars of cost optimization can become regular practices for your developer teams. So definitely take a look at all of these resources here. And this kind of concludes the developer track. Thanks everyone for joining, and take a look at the troubleshooting survey. So here you can provide your insights on your troubleshooting experience with AKS in general, share your feedback on what that's been like, the pros and cons, and all of your experiences there. So the survey will close after KubeCon, and if you're one of the first 150 people to complete it, then you get a $10 gift card. And then after lunch, we'll go into the operator track. Yes.
Hey folks, so there's slight change of plans because lunch is probably around or after 12:45 to 1. So what we'll do here is, originally we had scheduled the Ask the Experts panel at 4:45-ish. We'll move it now in the interest of time, and we have some experts in the room, a lot of PMs in my team. So they're happy to answer your questions. What I will request you to do is put your hand up, introduce yourself to each company, and where you are in terms of the journey, what you have to workload, those type of background will help us, and then you can ask your question. So, okay? We can go a quick round of intros. So my name is Karthik. Is it okay? Sounds good. So I'm Karthik. I am a PM on the AKS side, specializing in upgrades and cluster lifecycle management. I'll pass it to. So is there a mic? We'll need one hand mic. We can just put it. So Lucky.
Hello, I'm Lockie Evanson. I'm on the Cloud Native Ecosystem team where we represent some of the things you saw today, like ACR auto patching, our upstream investments in open source, and also our partners team. So, thank you.
Hi, I'm Ross Gulachi. I'm a PM in Azure for Upstream, specializing in what you might call exotic workloads in and outside of Kubernetes, things like WebAssembly, Hyperlight project, which recently was released, and various other integrations into Kubernetes upstream, and also AKS.
Hey folks, I'm Ahmed. I've spoken to you today a lot. I'm specifically working on the AKS Automatic project and a bunch of developer experiences.
Hello, I'm Saji. I gave a few presentations today, and my focus area is AI, GPU, and scheduler on AKS.
Hey folks, I'm Bob. I'm on Lucky's team, work with our ISUs and SIs, so any sort of third-party applications that you are considering, or marketplace and all, let me know how I can help.
And with that, we can just get started. If anyone has a question, please raise your hands.
I got one thing I want to say, because Sachi did such a great job at summarizing the kind of some of the operational cost optimization. So one thing that provoked me to sort of call out, because it's sort of abstract, but it's easy to miss. AKS is a kind of unique service in Azure, in hyperscale cloud, because it's the one service where Microsoft doesn't know your specific workload. We don't build AKS for your specific workload. We build to integrate features so that you can optimize your operations. And so when she was talking about leaning into the pillars of cost optimization, and she listed a whole bunch of resources that are not Microsoft resources, keep in mind that when you're thinking about cost optimization, the sky's the limit from your personal point of view about how you can drive your costs down using AKS. That's an important sort of step back from the idea that, we try hard to help you do that, but you can do even more by thinking hard about your specific workload. So I love that point. I thought it was great.
Anyone with a question?
You're all ready.
Yeah.
Any
Got it
feedback,
all.
questions, comments?
Anything? Yes.
Yes.
So that's the gentleman there.
Hello.
Very good.
Do we have any interface to optimize the resources? Like in the bucket, we have Instana. Drag and drop over there. You can just see all those resources are optimized along with that. Because the node which is not but utilized in the node pool, we can reduce the size of that at the runtime. And we can see somewhere in the dashboards or
Yeah, I mean, if you're using node auto provisioning as your autoscaler, it automatically does that for you. So you can change even like how frequently you wanted to re-look at what the utilization is for the node. And it can then create new nodes that are bigger or smaller just to pack that extra capacity, get rid of it. And you can also configure like how much buffer you want. So that doesn't really end up being a very tight node, and give you some buffer so that you can scale without waiting for a VM to provision. So that's from a node auto provisioning perspective, which actually changes the VM size. Vertical pod autoscaler can do this at a workload level, so it can look at how much resources your application is actually using, looking at historical data coming from the metric server. Then it can either suggest, and then you have to take action, or it can also automatically redeploy and update the resource requests and limits so that you're either not over provisioned, so you're not like setting, I want 3 CPUs, but you're not actually using all of that. And the other way around, like if you detects like your application is being killed for like going over the memory, then it can automatically change the memory requests and limits so that that doesn't happen.
In addition to what Ahmed said, I think there's 2 pieces. So one piece is cost management. So one great thing we do is export will give you the ability to see the cost per resource at the Kubernetes level, not just the virtual machine level. So if you're a platform builder, you can actually charge back to your customers exactly the resources, the load balances, the pods, so you get pod level introspection of the cost. So one thing is visibility under the cost, which we allow you to do using things like open cost. So there's portable APIs. So one thing is insight into the cost, and then just further to what Ahmed said is we're building tools to help you optimize your workloads in relation to that cost. So bin packing, scaling down when you don't need the extra capacity, and then scaling up just in time. So we have a commitment because cost optimization is a really big and important topic to our customers, to provide the tools and the features to help you be successful, to meet whatever your goals are. I will also say, Bob, you want to mention we have ecosystem partners that do this. Do you want to mention that?
Yeah, thanks. So we have several ecosystem partners which are very active in the space. One that comes to my mind is CastAI, that does an AI-driven optimization of your resources once they're deployed. And it even tells you like where in which particular like region you can do it, where you can save more costs. You can see a dashboard of all your resources, how you optimize it, where you place it, and all of the good things that we spoke about. So I encourage you to take a look at that, and if you have some other more questions, feel free to reach out and see how you can do a proof of concept and see if that helps you.
now there is.
Oh, wait.
Yeah, we got you.
Now we have more focus on observability, on applications. Whenever there is a customer data involved, right? Organizations are not ready to go into production. For example, Azure Managed Prometheus, Grafana, right? So let's, for example, Tier 1 applications, they don't want to consider collection of the metrics whenever there is a customer data involved in production. So how Azure is tackling this issue, or how you are convincing customers to get into production, or are they customers who are already on production? Because it's a genuine issue. Because whenever there is a customer data involved, let's say in banking or health industry, right? They are not they're not keen about collecting the metrics from Prometheus. That because it's on cloud, it's not on premise, right? So on the security part, right? How Azure is considering this problem, and what's the roadmap?
I think what I'm hearing from your question is about multi-tenancy and security to make sure that customer data doesn't leak between tenants, specifically in observability when you're logging and monitoring. So I think what we try to do with those managed services like Managed Prometheus and Managed Grafana is use industry standard APIs and data storage techniques so that we can export that data to whatever tool you have. So if you have a requirement to store it on premise, and you have a system designed to make sure that that customer data is treated independently, we can actually export it so that you don't. So, our investment is to give you the opportunity to use standardized APIs, not use a proprietary API that's only intrinsic to Microsoft, so that you can take the data and store it in your own tools as well. I know that doesn't answer your question entirely. I think the other challenge with multi-tenancy in a cloud-native world is how you build more, segmented infrastructure so that one infrastructure can't touch the next. And doing that in a cost-optimized way can be very challenging. We have different tools in AKS, like nested virtualization, to give you more stricter tenancy, but it's still very challenging, and I don't think I can give you a one-word answer.
Because container insights, it's retiring, and Azure is forcing, Microsoft is forcing to go to Prometheus-based alerts, right? And we are forced to use managed Prometheus only, right? We have open source Prometheus, open source Grafana, right? But still, we are forced to use because of the alerts. Container insights is getting retired, right?
Right.
So we are in a dilemma whether to use open source or not, or we are forced to use because we have to have a Prometheus workspace to have those alerts, Azure alerts in place, right? Other than that, we can't monitor.
Right. So So the question, I want to elicit a little bit of what you really want to end up at. So the difficulty that
customer identification data, whenever there is a transactional data, right?
Right, and how do you want it surfaced? Do you want it surfaced in the Managed Prometheus offering? Okay, and you're going to need granularity per tenant, for example. You want to make sure that that is something that you can target in a coherent way.
Yes.
Okay. That sounds like a wonderful statement of a problem space, and so that gives us the opportunity to go. The problem with integrating open source tools like taking Prometheus and making a managed service out of it is that while we're doing that, we need the kind of precise feedback of the feature set that you're looking for so that we can drive the managed service to that. There's nothing preventing you from using open source Prometheus, but of course, because it's just Kubernetes, right? But that managed service is the thing that the customers are telling us we need to provide for them, and your feature set is one of those things we need to keep in mind while we're making sure that Managed Prometheus gives you the result you need. So that's why I wanted to clarify, because that's great feedback and something we can do something about.
And are there any customers who are on production using managed Prometheus.
I don't know, Mars.
I think we have quite a bit of customers using managed Prometheus, but yeah.
Customer data, I mean CID, customer identification data.
Yeah, what I might suggest is the management, so the monitoring team are going to be here this afternoon. I would redirect that question to them and give you the best information. I think we want to understand your use case and see if we can meet your needs. So,
Sure, absolutely. Yeah.
The answer is yes.
yes,
for
I
sure.
will get you the right
But the
person.
details are the people that are.
They'll be here this
Yeah.
afternoon.
Sure,
I have something to add. So, when you look at like multi-cloud, hybrid cloud kind of strategy, that's where again third-party tools come in. A lot of people are using Datadog or Dynatrace. They have a self-hosted model where everything is completely running the customer tenant, nothing goes out.
Okay, I see there a problem because in banking sector, right?
Yeah.
The admission webhook policy
Yes.
does not allow Dynatrace agent to be deployed on system notebooks.
Okay.
So there is no way it can collect data from the workloads which are on system notebooks. So it doesn't give that amount of the granularity level of details of what my workloads are doing or what my system is, let's say resiliency of the system is not 100%.
Could you give her a microphone?
So I just want to add that we are from the monitoring team. We will connect with you at the break and we'll try to look at how we can help you better.
Yeah, exactly. It's an interesting challenge, doing this work.
Questions? Let's see if
Yeah,
we
yeah,
can
yeah.
get more in before you go too deep.
Yeah, I was going to elaborate on that, but any other questions about any aspect of AKS and the work that we're doing here? How you want to use it? Issues you think are involved from your point of view? Sure, sure. Yeah, get that one. He's got it.
So in the past 6 months, we have upgraded like couple of Kubernetes AKS versions, right? So what I have observed is whenever I upgraded a version, the VM scale set in that zone is not available, but we are paying for it. Okay.
Yeah.
We are paying for it, but what happens is at least for 6 or 8 hours, the VM scale set is not available in that zone. And we raise a ticket with MS and they just hang on saying that, okay, we'll add it. Okay, they say that we will add it, but of course I know that automatically maybe somewhere else it gets evicted or some workloads get evicted, then it is scheduled for our subscription. So this is a major problem which we see, that too in production as well,
I see.
not only in test subscriptions.
Got it. So when you say it's unavailable for 7 to 8 hours, I just want to understand in terms of, thanks for raising it, so there's something for us to probe further. Do you use anything like max surge and I want to understand max surge and PDBs, like do you use them when you're
Yes, we do. We do.
And what type of upgrades are you doing? Are you talking about node image, weekly type of thing, or is it like a cadence, from a cadence perspective?
No, its Kate is the entire cluster upgrade.
Cluster upgrade, okay, got it. So you do it at a test dev and then you move to production.
Right.
Got it. So what would be the, I'm just trying to understand in terms of the configuration, right? Because if you're talking about not available, one of the things that we covered, PDB.
Those are on-demand node pools.
On-demand node
right?
pools, okay.
So we are paying pay per use. We also have reserve instances. Okay, like we have reserved for 3 years, but still, this issue I see in production again and again. Okay, from past 6 months, a couple of times I have seen this issue. Whenever I upgrade on production, around like 6 to 8 hours, it's not available. No, thanks to us, because what we do is, let's say with the one system node pool or a user node pool, we have it in 3 different zones so that our service doesn't get impacted, right? But in one of these zones, that the VM scale set is not available. So cluster operation is in failed state,
I see. Yeah. Okay.
but our services are working because they're scheduled on other zones, high availability, right? But still, this problem is there. We have to spend time to remediate this issue. This is just a feedback.
Makes sense. Okay. So something that I'll connect with you and
Sure.
find out more on that.
Yeah.
Yeah, and just this afternoon, we're going to talk about improvements we're making to the upgrade process, including improvements we're making to the events you get out of an upgrade process, which may help you be able to trigger these things. But hear what you're saying. Thank you for the feedback. Anything else? Any other questions? Otherwise,
It looks like we are getting
ready for lunch?
Yeah.
Everyone ready for lunch? Okay, please feel free to find us over lunch as well. Happy to take more questions. Thank you very much.
Thanks a lot.
Thank you.